Hi, this is Satish teaching Big Data Hadoop on behalf of Excel online classes. So let's start with our demo. So here we are going to, in this class we are going to understand what is data and what is big data and how much data can be called as big data. And of course what are the sources which are collecting this data and why we are collecting all this data, right? So let's try to answer our first question. So what is data? So data could be there in various forms, right? So it could be there in our basic text form, that would be txt files, JSON files and XML files. And before talking about these text-based files, the very first thing which we think about is basically databases, right? So everything which is there in our databases is data, but it is in the form of tabular form, right? It would be tables and columns. So it is purely structured data. So everything which is there in our databases is purely structured data, and the rest is semi-structured and unstructured. Semi-structured XML comes under semi-structured, and any other text file basically we would call it unstructured. Okay, it's not in your in tabular form, right? So there is no clear demarcation like this is going to be the column. Okay, so what is big data? So let's, and along with that of course we have various forms of data. There is multimedia data, which is completely unstructured, and we have Word and PDF, right? So various forms of data, or data in emails, all these are examples of unstructured. So let's try to answer the next question. So what is big data, right? So till now we have been talking about gigabytes and at the most terabytes, right? Now world has started talking about tens of terabytes and hundreds of terabytes and then petabytes. So the numbers which you see here, right? Facebook has around 2.5 petabytes of data, and it keep on getting 15 terabytes of data a day, right? So we have started talking in terms of bigger numbers than till whatever we were talking in terms of, right? So Facebook has this data, that is volume. So this is the volume of data which they have, and this 15 terabytes per day is the amount of data which they are adding every day. This is called velocity. Velocity is the speed at which they are adding data to their existing system. So they have this 2.5 petabytes of data, that is volume, and they are adding 15 terabytes a day, that is velocity. So if you have huge volume of data, or you have good velocity, okay, and then if you have variety of data. So basically big data is trying to solve all these three problems together. There is huge volume of data, storing huge volume of data, and if the amount of data which comes in, that is scalability, okay, this scalability issues, and along with it you have variety of data. We are talking about variety because to process unstructured data it takes a lot of time, definitely, okay. So it's also about the computation as well. So it is about storage and computation. So as we see, databases and Excel data, or basically XML can also be called as structured, semi-structured. So remaining all is unstructured, and you have your streaming data, that is definitely unstructured, completely unstructured, right? So now if you see this, okay, basically statistics say that every 1.2 years data is doubling. So if we have 100 terabytes of data now, so the company would expect the amount of data to be 200 terabytes in the next 1.2 years. So based on that projection, this EMC Square has projected that from 2009 to 2020, okay, data is going to grow by 50 folds across the companies and across the domain. Okay, and we are right now, we are somewhere here, then okay, somewhere here, right? So we have a lot of scope for the data to grow. Basically, we are just in the initial phases of this big data. So if you see the variety of data, so you would see two bars here. One is bigger bar and one is smaller bar, smaller one, right? And the bigger one is unstructured data, and the smaller one is structured. So statistics say that 90% of the data in this world is unstructured, and companies feel that there is a lot of value in that unstructured data, and they are trying to process it, but it's time consuming. But with the help of these big data technologies, I would be specific, Hadoop, okay, it would help in solving the storage problem. That is, we can just store any amount of data, there is no limit, and we can just process it in whatever time we want to. So these are a couple of comments which bigger and big companies are saying about this Hadoop or big data basically. So this McKinsey, based on their analysis, they say that analyzing big data sets will become a key basis for competition. Okay, so every company has started implementing big data practice or Hadoop actually. Okay, and Gartner also says very similar things. Okay, so it says we should not delay implementation of big data. So that's the reason most of the companies have started as soon as possible, and it specifically says about Hadoop. And Forrester research also says about big data and Hadoop basically. So from where all this data is coming and why these companies are using this data, right? Of course, it could be source, could be anything, but why they are actually collecting all this data. So let's take one example wherein like Google usually share their analysis usually, right? So and Google would say every 6 months or 1 year, it would say like so and so person is the topmost searched person in a particular country basically, right? So how would they say it, or let's see like what's the kind of data which they are storing. So how many times we would do Google search? So at least I would do at least like 30 or 40 times a day, right? So I'm taking a bare minimum number of 1 million people doing Google search a day, using Google search a day. Then it would be 1 million into 30, that would be 30 million searches, right? So Google, so whatever we search, basically we are not just consuming the data, we are also generating data. So Google will track what all searches has been made, from which part of the country or which part of the world it has been made, and at what time it has been made. So all these things would be tracked by Google. So now coming back to our numbers, so it's 30 million searches a day, and it would be again like if you take 1 month, then it would be 900 million searches a day, and that would be the bare minimum number which I have took. Okay, so that's quite a huge actually. Okay, and coming to this e-commerce companies are building something called recommendation engine, wherein they want to recommend products to their clients. So whenever a particular user visits their site, they would obviously show some recommendations on the right or left or the bottom of the page. So to do these recommendations, they have to study a lot about this user, so they would like to know as much as possible about a user, everything like what he has added to cart previously and he didn't buy, okay, and something which he has visited previously. They would also track your cookies, okay, so they would try to collect all this information about users interest from various sources, and all this data would be very huge, very huge. So it would easily run into tens of terabytes a day. And similarly, Amazon also, like every e-commerce company, has its own use case or its own algorithm to develop this recommendation engine. So I would discuss one more use case wherein this telecom, like phone system, basically like this telecom company is using a use case wherein they would just send these messages to their customers saying that if you do X amount of billing, then we will give you some discount. So if I just take some numbers, like some example basically, so they might send a message saying that if you make 800 rupees of billing, and they would give 20% of discount. So how they are coming, or how they have come across these numbers, actually how they have calculated these numbers, right? So they have this history of data. Suppose I have 3 years or 4 years of relationship with this company, so definitely they want to track every damn information about me. They would obviously be having my billing information. That's the least information which they can have, right? So of course they are going to have a number of and other things, basically about my STD call details, about my ISD call details, about my local call details, about my messaging behavior, right? So all this information will be there with them. Okay, so how did they come across this number? Is they would analyze. So in this particular company is using this use case. Okay, they have just took the average of all these um, billings from 3 or 4 years. Basically, it's not just average, but they have their own system again. Okay, but that number has come to 650, basically 650 rupees, and they have offered 800. If I make 800 rupees of billing, then they are going to give me 20% discount. That would be 800 minus 20%, that would be 640, right? It's the same as my range, basically. So I would obviously take this offer, and I would make 800 rupees of calls a month, and then I would get used to it in 6 months or so. And then once I got used to it, then this company has stopped giving me the discount. So I would end up paying 800 rupees after this discount period is done, and then I am used to making these calls, and this company has increased its billability, right? So this is just a simple use case where one of these telecom company is using to increase its profitability, or to give certain offers to their customers, basically. So of course, similarly, every company has its own use case, but here whatever we are interested is data, right? So we are interested in data. So big pharmaceutical companies, they do a lot of analysis on what kind of medicines they have to do research on in future, basically. Okay, so it's pretty huge. It's pretty huge. They do a lot of research. The data itself would be huge, and then they would collect a lot of samples, and they do a lot of test runs. Okay, fine. So basically, ultimately, the point is companies are interested in data to see the behavior. Basically, they just want to know reporting. They just want to generate some reports and understand why things happen again, right? And then what's happening right now, and what might happen in future. With the help of this machine learning algorithms, they are able to predict things now. Okay, so that's about analysis. right? So the basic analysis, the basic fund of analysis is the more data you have, the better analysis you can do with simpler algorithms. Even if you use some complex algorithm on some minimal set of data, you cannot predict something very well. Okay, if you have more information or more data about a particular user, then you can predict him better, even if you do very simple analysis. Okay, so that's how analytics are based on, basically. So they would need huge amount of data to do good analysis, and that's how these companies are just interested in all this data, and then they started running into this big data problem, right? So anything which is above 5 to 7 terabytes, I can say, okay, can be considered as big data actually. Okay, anything above that. So now so we have talked about this bigger term called big data actually. So this is just, it's not a technology, it's just a term which is used to describe this huge amount of data and the technologies which can handle this data, right? So Hadoop is a leader in big data stack basically. So let's see how Hadoop works, right? So Hadoop is basically open source software. It's free of cost, and it is, you can download the source code of this software, and then you can just make any changes if you're capable to do so, and then you can just sell it on your name actually. No one will stop you. If for reliable, so when we are talking about reliability, we are talking about reliability of data here. So once we have our data in this Hadoop system, then we want to make sure that it is available. So even if couple of systems go down, that is, let me just discuss about, yeah. So Hadoop basically works like this, right? So it would work on a lot of systems actually. You would not have just a single machine working for it, so you would have hundreds of machines working to solve your problem actually. Okay, so let me just take some number here. Okay, let's assume we have a couple of systems, and if we have some data A, okay, if we have some data A, then it would actually be kept 3 times. That is by default, and we can configure it, of course. So this data A would be there 3 times, and if one of the machine goes down, then Hadoop would actually make sure there is another copy of the data in some other machine. Okay, it would copy it from this replica, that is available replica, and it would make a replica by itself. So it's automated basically. Of course, we have to do a couple of things to do that, which we are going to discuss in our class. So we have a lot of internals about how this works actually. So I'm just trying to give you a like 10,000 feet view. So that was about reliability. And coming to scalability, we have 2 terms, vertical scalability and horizontal scalability. So vertical scalability is about okay, so vertical scalability is about increasing the capacity of your existing machine. Let's take, you have a system, and this particular system is, okay, if I take some production grade numbers, so previously production grade systems were 8 GB RAM and then 500 GB of disk space. Okay, and they have, for some reason, like they felt like they have to increase the capacity of this machine. Obviously that was not good enough, so they have bought a new, obviously these people would have bought a new machine. Yeah, that could be around like 18 GB of hard disk, or I can just say 24 GB RAM, sorry, and then 2 TB of hard disk. And then this previous machine they would just discard. So in this particular case we are trying to increase the capacity of same machine. At any point of time we have this machine only, right, and we are trying to increase the capacity of that machine, right. So this is called vertical scalability. So there is, if there is a way, let's assume like there is a way wherein your previous system, that is your 8 GB RAM and 500 GB disk, and along with that we also have a bigger machine, that is 24 GB RAM and 2 TB hard disk. So both these machines are working together. Let's assume that. So if there is a way wherein both of these systems can work together, right, and if you need more capacity, then you can just buy another machine and you can just add that to this network. So this is horizontal scalability. You can just add a system to the existing nodes, basically existing, you have like 99 machines, then you can just add 2 more machines and you can just increase the capacity of that your overall system actually. Okay, so that is called horizontal scalability, and Hadoop is horizontally scalable. And we want to talk about distributed computing, right? So let me just focus on that a bit. So we have various systems, as I mentioned. This is distributed storage system, right? And okay, so before that let me just consider a single system. Of course you have a single system. Okay, you just have a disk and you have some RAM and you have CPU. So obviously whenever you're processing data has to be loaded into RAM, and then it has to be processed, and then it has to be written back onto the disk, right? So just to load this data into RAM, it would take 2 hours. Okay, let's assume we just have like 1 million records, or I would say 100 million records, 100 million files, I would say, sorry. So you have 100 million files, and just to process them, like it took 2 hours. Let's assume you're doing similar thing on Hadoop. Let's see how it would actually work. So obviously now you understand you have multiple systems working together, right? So let's just name them as 1 and 2, and then probably we have 100th machine. Okay, So in this particular case, we have 100 machines working together to solve a problem. And in Hadoop, basically when you try to put these 100 million files, then 1 million records would, sorry, 1 million files would be placed on each of this system. Okay, and when you try to process them, these 1 million here would be processed on this machine. Okay, I'm sorry, I just named them wrongly, right? So I hope that would be okay with you guys, right? And each of this system has 1 million records, sorry, 1 million files again. On the whole we have 100 million, right? So we have 100 systems, so it is divided homogeneously, right? And then each of this 1 million are processed on these 100 machines, 100 different machines. So obviously your time would come down by 100 times approximately, okay, at least close to 100 times. So that would be 2 hours is equal to 120 minutes by 100 times, right? And okay, so this by 100, so is equal to 1.2 minutes is equal to 80 seconds, something which was taking around like 2 hours, now it takes 80 seconds, right? So that's the power of distributed computing. And obviously, as Hadoop is basically distributed system, completely distributed system, its storage is distributed and its computation is distributed. Okay, and this is how it's solving both the problems, that is storage problem. So it's not like you are going to have only your data only in single system, right? Your data is going to be on multiple systems, so it's all about, you're just going to add some infrastructure, that's it. So and you can just increase the overall capacity. So we have two major components in Hadoop. So one is HDFS, that is Hadoop Distributed File System, and the next one is MapReduce. So HDFS takes care of the storage part and MapReduce takes care of the computation part. So I've discussed like once you put the data, so it would be distributed among the various systems, right? So that would be taken care by this HDFS. And I've also mentioned like each of this 1 million 1 million files would be processed on the respective machines. So that would be taken care by MapReduce. So MapReduce is a programming framework wherein it divides this job into multiple tasks, and each of the tasks will be ran on in a single system. So that is how each of the node would be working for us to solve the problem. So technically each of the machine is called a node, and a combination of all these nodes is called a cluster. So that's how, to simplify it, that's how I would mention it now. Okay, so we are going to discuss more in our class about all these concepts, distributed computing concepts. Okay, yeah, so now we understand that, okay, we don't understand about how Hadoop is economical, right? So we understand that Hadoop is reliable, and we understand that Hadoop is scalable, but we don't understand how it is economical, right? So Hadoop basically runs on commodity hardware. Commodity hardware is easily available hardware, easily procurable, that is you can just use any of your machine actually. So usually the standard configuration used for Hadoop is 24 GB RAM and 4 TB hard disk. Okay, that is the commodity hardware. When we talk about production grade systems, I'm not talking about our normal laptops or normal systems which we use. This is about production grade systems. Okay, that is, so what is commodity hardware? That is cheaper hardware, something which is cheap and easily available. If Okay, to make you understand this better, I would just take a simple example. If you buy something which is standard product of a particular manufacturer, then he would just sell it at cheaper cost. But if you want them to manufacture something specially for you, right, so it's not mass, they're not producing them massively, they're going to produce it only for you, okay, specifically on a custom order basically. So they are going to definitely charge you very high. Okay, so that's exactly what happens with RDBMS or normal traditional systems actually. Okay, so we usually they buy big much bigger machines, and they end up paying a lot of money on infrastructure, and obviously they have to pay a lot of money for software as well. Okay, and coming to flexibility, so good part in Hadoop is in your normal databases, right? So first thing you would do is you would create schema, that is your table and all the columns in that would be defined, and then you can actually dump the data, right? But in Hadoop it's reverse. You can just dump the data and then you can think about your schema. Okay, so Hadoop is basically dynamic schema, wherein you can just create a schema at any point of time you want to, and it could be anything. Okay, and a particular set of data can be processed using multiple schemas. So the same set of data can be seen with multiple views actually. Okay, so that's the advantage which you have in Hadoop. So we are going to see all of them, like how it is possible actually, right? So who uses Hadoop? Like, of course, this is not just these companies are using Hadoop now. Everyone is using Hadoop now. Okay. Now we have different tools in this Hadoop jungle. So I would just call it as Hadoop jungle because we have various components called Hive and the pig and Impala. So all these are named after animals, and we have another component called Zookeeper, which would actually take care of all these animals. So I just named it as Hadoop jungle. Okay, so different tools for different skill sets. So if you are from Java background, then you have something called MapReduce. If you are SQL background, then you have something called Hive and Pig. And if you are from scripting language, then you have Pig. And if you are from workflow side, okay, then you have something called Uzi. So for every background there is something or the other in this particular Hadoop basically. So these are various animals which are available. So when I say animals, of course I'm using it just from, like, I'm just using it. So these are called ecosystem components. So this Hive is the one which would actually give you a kind of SQL like, okay, interface to deal with Hadoop. Pig is a scripting language which works with Pig Latin, and Scoop is to interact with RDBMS. So if you have some interaction with RDBMS and Hadoop, then we are going to use Scoop. And then HBase is the one wherein we can just do some random reads and writes. Okay, of course Hadoop basically has some drawbacks basically. So that they are covered, they are actually filled by HBase. Okay, and then FluentNG is about streaming data, and Impala is a faster version of querying the data, and Zookeeper is the one which takes care of all this, and Uzi is about workflow engine, and Hue is Hive user experience, and Spark is again a faster version of processing the data basically. Okay, so these are ecosystem components which work on top of this HDFS and this MapReduce, right? So that's about these ecosystem components, and we are going to see all of these ecosystem components in our class. So we are going to install them, configure them, and work. Okay, so I'm going to share material for each of this component, and we are going to practice them in class. Okay, so that's about animals, and it's not about only these components, and we are going to discuss some more components than this actually. Okay. Right, coming to Hadoop distributions, so we have So this Hadoop distribution is basically licensed by Apache. It's okay, and Cloudera, Atomworks, and all these actually provide a commercial distribution of this Apache Hadoop. Okay, these are commercial distributions. So we have Linux and we have Red Hat Enterprise Linux, right? So Linux is basically the open source or free version actually, and then Red Hat Enterprise Linux, what they did is they took this Linux and they added some more components or UI basically, so ease of using it, ease of using this Linux, and then they have just, they are going to give you some support whenever you face some issue, they are going to solve it for you. So it's exactly same relation we have with Apache Hadoop and all the remaining distributions. Okay, and Cloudera is having around like, Cloudera is having around like 55 to 60% of market share, and Hortonworks is having around like 20 to 25. So combinedly these two has 80% of market share, actually 75 to 80% of market share. And why they are so much famous is Cloudera and Hortonworks are pioneers of this commercial distribution, and Cloudera has added a lot of components by itself, and Hortonworks has also come up with a lot of components. And along with that, Cloudera has a person called Dow Cutting, who is actually the inventor of this Hadoop. So the guy who has actually created this Hadoop is with Cloudera. Okay, that is a selling point for them. And this guy Dow Cutting was actually working with Yahoo. Okay, when he created this Hadoop, right? So he would definitely have a team. So some of the team members are there with Hortonworks. Okay. Some remaining all have come up pretty late actually, but still they're catching up. Okay, but on the whole, if you work with two of the commercial distributions, then you can actually work with any of these commercial distributions, right? Okay, so in our class we are going to work with Apache, Cloudera, and Hortonworks. So we are going to do practicals on all these three. It's not like one. Okay, so first we will start with Apache, and then we are going to understand the internals of Hadoop, and then we are going to use Cloudera and see how it is different, and then we are going to see Hortonworks and how it is different, and we are going to work on all these three. Okay, and coming to Hadoop on cloud, right? So as I mentioned, like Hadoop usually works on like distributed systems, right? So it would be hundreds of systems, or it could be 30 or 50 or tens of machines basically, right? So when a company is trying to evaluate this Hadoop software, so they would definitely not buy all these machines by themselves, right? So they would want to take them on lease. So I would just give you a scenario. Suppose you are doing your proof of concept, that is, you are evaluating this Hadoop software, and then you need this 50 machines, 50 nodes just for a month, okay, till you do that proof of concept, right? So you don't have any other way to get those 50 systems. Obviously you're not going to buy them, right? So you would definitely go with cloud. Okay, you can just create your systems on the fly. You can create your systems on the fly, and you can just delete them once you are done with them. So that's a flexibility which cloud gives us. Okay, so as I mentioned initially, most of the companies, when they are evaluating this Hadoop, they would like to go with cloud, and in the cloud basically we have a couple of companies which are providing these services, couple of vendors, that is Amazon is a one, and AT&T is there, Google is there. Okay, Cloud Rack, like there are a number of companies actually, but Amazon EC2 is the one which is mostly used and which has all these security based certifications or assurances basically. Okay, even a federal government project can also be executed on Amazon EC2. They have that certification actually. Okay, so mostly Amazon EC2 is the one which is used, and it is also providing these services at a bit cheaper cost actually. Okay, and in our class we are going to see how we can actually work with cloud, that is Amazon EC2, and then we are going to create couple of machines, that is at least 5 to 6 systems, and then 5 to 6 nodes, and then we are going to see how Hadoop actually works on it, and how we can actually work with your cluster which is there in cloud, or a cluster which is there on your remote environment, right? So that would actually give us a feel of real-time environment, and that's when you understand all the real-time concepts basically. Okay, so we have certifications as well for Hadoop. So Cloudera and Huttonworks are the two companies which are providing this certification, and Cloudera and Huttonworks both are equally recognized, but Cloudera would definitely have an edge over Huttonworks because Cloudera's sales are a bit higher, right? So definitely people who use Cloudera might want to have Cloudera certification. So yeah, so coming to this certification, so basically we would have 55 to 60 questions, and 70% is a pass percentage, and Cloudera would charge $295, and Hardwareworks would charge like $150 for the exam. Okay, now coming to the job trends. So this is how like the trend has been. So if you can just see this graph, so this opportunities has been growing, and it just keep on growing basically. Okay, and right now even the billing is very pretty high than other technologies. Okay, this is just an analysis which is shared by this transparency market research, right? So they have mentioned like companies are ready, so this is the amount of money they are expecting in millions, 48,300 millions of dollars they are expecting to be pumped into this big data Hadoop market actually. And then we are right now we are in 2012 2014, so we are somewhere here, right? So we are somewhere here actually, yeah. Okay, and there is a lot of money to pump in mostly. Okay, so we are yet to realize the total market for this. We are still in the initial phases of it, so fine. So okay, so basically we are going to once we are done with all this discussion, right? So we are going to create our own Hadoop cluster on our laptops, and then we are going to work with HDFS and MapReduce extensively, and then we are going to work with ecosystem components. Again, we are going to work on each and every ecosystem component, and then we are going to see the real-time environment, how it would be, and how things would be, right? And then we would discuss about POCs. Okay, so we are going to discuss some proof of concepts, and then we are going to discuss interview questions, and then I'm going to share these practice questions for certification. Okay, definitely like certification would give you some edge basically, and send sample resumes. Okay, so these resumes are going to range from like various experiences. Okay, and then we have this material to practice for each and every component. So yeah, so we are going to share all of them with you guys. Okay, so right, so that's it from my end. So okay, so you can always get in touch with us on this particular. Okay, these are the details wherein you can just get in touch with us. Okay, yeah, thanks guys.